At WMG, we are all about research with impact. The research coming out of the verification and validation group is influencing international standards and regulations to enable the safe introduction of automated vehicles. Our mission is to create knowledge and methodologies for industry to prove a technology is safe for society.
By incorporating our key stakeholders in our fundamental research questions, we can ensure that we design our research to address their concerns adequately, hence demonstrate safety and in turn lead to greater adoption of this revolutionary technology.
In order to prove any type of automated driving system is safe, we essentially need only three key things. The first thing that we need is a set of test scenarios. The second is a test environment to execute those test scenarios in, and ultimately we need a safety argument to prove that the system is safe or not. When we are generating test scenarios, we look at two different approaches. The first approach involves a data-based approach where we are analyzing accident databases or insurance claim records or real-world data to understand trends that lead to accidents or near-miss scenarios, and then we use them for stress testing the automated vehicle itself. The second approach that we use is a knowledge-based approach, where we are analyzing the system design of the automated driving system to understand how it could fail. Once the scenarios are created, we need a common format that can be used by all stakeholders. And that's why we have created WMG's Scenario Description Language, or SDL. Because we will have lots of scenarios, we need a common repository to store them. For this, WMG, in collaboration with DeepenAI, have created the world's largest public repository of scenarios, the Safety Pool Scenario Database, which all stakeholders could use to share scenarios with each other. Because these scenarios will need to be run many times, it will not be plausible to run them over and over again in the real world. And that's the benefit of using simulation-based testing, where you can run millions of these scenarios in an efficient manner. And this would complement real-world testing. Once you've executed all these scenarios in a variety of test environments, we then need to use the evidence generated to create a safety argument. And that is done by analyzing the results of each execution to check if the automated vehicle displayed safe behavior or not. And that decision is driven by a set of rules for the automated vehicle for the environment it is going to operate in.
The high-value manufacturing catapult at WMG supports the verification and validation team. By enabling us to work with policymakers and industry, we create an environment in which we accelerate and de-risk the introduction of next-generation transport technologies.
The same questions are being asked in the maritime sector and in aviation. A lot of the solutions could be very similar. By working together and collaborating across those three domains, we can make all of the domains safer in a short amount of time.